Here is number 19. It says a parallelogram ABCD has coordinates A, 0, 7, and C, 2, 1. Which statement would prove that ABCD is a rhombus? So let's start out with this whole point that figures are all named in the order of their vertices. So if A is here, then B is going to be over here, C would be down here, and then D would be over here. So just to give you an idea. So when they give you the coordinates of A and C, we know that A and C have to be one of the diagonals. So the first thing I highly recommend is using some graph paper. So what we're going to do here, since they didn't give us the X and Y axes, we're going to draw that. This is our x-axis, this is our y-axis. So A is at 0 on the x-axis and 7 on the y-axis. So 0 on the x and 1, 2, 3, 4, 5, 6, 7. That's going to be where A is, 0, 7. And C is at 2 on the x-axis, 1 on the y-axis. So over 2 and then up 1. So that's going to be where C is, 2, 1. So it says, which statement would prove that ABCD is a rhombus? So I always ask myself, what did they give me and what do I know? They gave me a diagonal, right? A and C, when we connect those, again, you're going to see that that forms one of the diagonals. So B is somewhere over here, D is somewhere over here. So what do we know about the diagonals? The diagonals of a rhombus are perpendicular. Okay, so here's the symbol for perpendicular. So what do we know about perpendicular lines? They have negative reciprocal slopes. So if I can find the slope of AC, which is up 1, so remember slope is the change in y over change in x. So we're going to start at C. I'm going to go up 1, 2, 3, 4, 5, 6 units on the y-axis. And then from there, I'm going 1, -2 units on the x-axis. When we reduce that, that comes out to be 3 over -1. So I know that the slope of this diagonal is going to be up 3, -1, up 3, -1, which means that the slope of line segment BD, the other diagonal, so line segment BD, I know that the slope is going to be the negative reciprocal, which is going to be, instead of negative, positive, and then reciprocal means to flip the fraction. So 1 over 3. So therefore, the answer to this question is going to be choice 3. So if we look at the other answers, the slope of line segment AB is 1 over 3, and we just said that the slope, that is not correct. So AB is not, well, we don't know. It's not necessarily 1 over 3, and it probably isn't according to this picture. The length of BD, so that would be the length of this diagonal, is the square root of 40. I don't actually know if that's necessarily true. I know I can find the length of the segment AC. So segment AC, again, if we make that right triangle, it's up 6 over 2, so 6, 2, and then if we find the length of that diagonal, so 6 squared plus 2 squared equals AC squared. 6 squared is 36, 2 squared is 4, that's equal to AC squared. 36 plus 4, that's 40, equals AC squared. The opposite of squaring is square rooting. So I know for a fact that the length of AC is square root of 40. Which is not necessarily the length of segment BD, and in a rhombus, they're not going to be the same length. Now, the midpoint is going to be half of the slope, so if we start at C and we go up 3 over 1, okay, that's going to be the midpoint of this line segment, which is at 1, 1, 2, 3, 4, but that doesn't prove that that's a rhombus. So the only way to prove that it's a rhombus is we know that the diagonals are perpendicular. So let's look at example number 20. It says point C is on line segment MN such that MN is to QN is equal to 2 to 3. So if M has coordinates of 3, 5, and N has coordinates of 8, -5, what are the coordinates of Q? So again, the thing that I'm going to do is I'm going to graph this, because that's the easiest way to do this. So I'm going to take my graph paper. And M is at, again, X, Y. So it's over 3 units on the X-axis, and this is my Y-axis. So over 3, 1, 2, 3, 4, 5. That's coordinates of M. And N has coordinates of 8 on the x-axis, negative 5 on the y. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. I'm just going to move this up here. So the coordinates of M, we said were at 3, 5. And then the coordinates of N, which is right here, is at 8, negative 5. So in order to divide a segment proportionally, what we're going to do is we're going to find the slope of this line segment. So once again, the slope of any line is the change in y over change in x. So I'm going to start at N, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to make that right triangle. So 10 units on the y-axis, and then from that point, 1, 2, 3, 4, negative 5 units on the x-axis. So that's step 1. Step 1 is to find your slope. Then step 2 is you're going to divide the slope by the total number of parts that you want your segment to be divided into. Total parts. Sorry about that. Total parts. So if we take this, we want 2 parts to be closest to MQ, and we want QN to have 3 parts. So 2 plus 3, that's a total of 5 parts. So we're going to divide by 5. So 10 divided by 5 is 2. Negative 5 divided by 5 is negative 1. So now we're going to start at N, and we're going to follow that new slope. So we're going to go up 2 over 1. And if you don't end up back on your line, then that's how you know you made a mistake. Up 2, negative 1. Up 2, negative 1. Up 2, negative 1. Up 2, negative 1. We're back to point M. So now you can see we have 1, 2, 3, 4, 5 total parts. So in order to find Q, we want from M, we want 2 parts, right? So 1 part, 2 parts to be MQ. And then from Q to N, we're going to have 1, 2, 3 parts. So that means Q is going to be this point right here. So we'll start at the origin and we go over 1, 2, 3, 4, over 5, up 1. So the coordinates of Q are going to be at 5 units on the x-axis, 1 unit on the y-axis. So your answer is choice 1.